Again, kumusta? I hope everybody is okay. And again, we will also be discussing a topic in differential equation. So this time we have the second to the last topic and the solution to the first order, first degree differential equation. So this time we have the Bernoulli equation. Now, Bernoulli equation is very close to a linear differential equation. So that is why this differential equation can be transformed into a linear DE, no? So by substitution. So if you have to write our equation, the Bernoulli equation in its standard form, this is how it looks like. So it is a Bernoulli equation in Y, no? So very close to the linear differential equation. The only difference of this equation to the linear is the presence of the expression y to power n when that is Bernoulli in y. So if that's Bernoulli in x, so the difference also is the presence of x to power n. Now for the values of n, no, so these are constant, and this constant cannot be equal to 0. Because if this assumes a value of 0, then the d is actually linear, no? So kung ma-0 ng imuhang n, then it's good nga wala na siya mag-exist, no? Then it is a linear DE, no? So if your n also is equal to 1, no, then the DE is considered also as a VS DE. Now, so any other constant value for your n except for 0 and 1, no? So that can be a value of your constant. Okay, now, how to reduce our Bernoulli equation to linear form? Okay, so this is what are we going to do? Now, this type of DA can be reduced to a linear DA by substitution. So we have to consider Bernoulli equation in Y. Okay, suppose this is a Bernoulli equation in Y. And then we have to remove the expression that makes this equation not linear. No? So it's either I have to divide with y to power n, or I have to multiply with y to a power of minus n. So if you have to multiply to y to power n, then the value of the power of your y becomes 0. So as if your y will no longer exist on the q's of x function. Okay? Now distribute, but the y to power of minus n can now be present in the first, so with your last term, with your second term, no? Now, ang atong first, so doon na kay y to a power of minus n dy dx. The second term, we have the piece of x. But since your y is originally containing a power 1, then it becomes minus n plus 1 as the new power of your y in the middle term. Now, the q's of x is already free from y to power n. Okay? Now, medyo, wa na to ma-attain ang atong gusto nga unsa, mahimo siya nga linear. Okay, but there's no substitution yet that is being made, no? Okay, so because of that, I have to look for another approach or another option to make it as linear. Then I can maybe say, let's say, let your z be equal to this expression, y to power minus n plus 1. And if I'm going to take the differential of your z, then that is equal to the minus n plus 1 multiplied with your y under a power rule. So minus n plus 1 is subtracted with 1. So what is left is the y to power minus n with a dy. Now I'll be looking for a substitute of this. So if I have to define the y to power minus n dy, then that can be replaced out from this equation with the dz over the constant of minus n plus 1. So, pwede na ko mag-substitute to this equation in terms of z. Okay, so what is my equation form by substitution? We have a y to power minus n dy, which can now be dz over the minus n plus 1 with the dx in the denominator plus piece of x. Okay, so we change that according to the substitution. Okay, so we have the q's of x. So the only difference of this equation to consider this as linear DE is the presence of minus n plus 1 in the denominator or in the derivative term dz over dx. Okay, so if I'm going to multiply with the constant of minus n plus 1, then I can have dz over dx or dz dx, then plus. So this is multiplied with the constant of minus n plus 1 times the piece of x, then times z. So we have also the right-hand member, which is a product of that constant with the q's of x. Now, this is already linear and variable z. Okay, now, being linear, pwede na ko mag-solve. I can now continue finding the integrating factor. So we know that the integrating factor is the exponential of the integral of the piece of x. But the piece of x is now associated with a constant factor of minus n plus 1. But still, this is a function in x and this is integrable. Okay, so I can solve if there is a specific value for this constant factor and the function. So I can now proceed with its integral. So I already have the value of the if. So once the if is determined, then I can continue finding the general solution. Okay, so what is the general solution? Because it is linear in our dummy, in terms of our dummy variable, so we can have z times the if. And that's equal to the integral of the q's of x. But the q's of x is, because naman rin ito ang linear in z, no? Then that is multiplied with the q's of x times the if. And we have to integrate with the variable of integration, which is x. Okay, so do the substitution. So, we can also restore at the same time our variable y from this substitution ganina. Okay, so left-hand member is... Okay, what is our left-hand member? Okay, so by substituting our z, then it becomes y to a power of minus n plus 1, then times the if. So, that's the integral of the q's of x times the minus n plus 1 times the if. So, pwede na ka mag-integrate at the same time, you are now restoring your variable y. Okay, now, if we have to summarize what we did, no? So, these are the steps actually in solving a Bernoulli equation. First, you have to write the dE in the standard form of a Bernoulli equation. So if that's Bernoulli in y, so take this as our guide. Bernoulli in x, so that's our guide. So after writing the equation in the standard form, so you can now possibly solve or identify your piece of x, your p, or your q, then your n. No? So pwede na ka mo continue into the evaluation of the if or integrating factor. Where integrating factor for Bernoulli in y can be this one. Okay, so if is equal to the exponential of the integral of minus n plus 1 piece of x dx. And if it's Bernoulli in x, so we also have a formula for our if. Okay, then last is to find the solution. Okay, obtaining the general solution, so Bernoulli in y, okay, y to a power minus n plus 1 with your I multiplied with the if, and that's equal to the integral of minus n plus 1 times the q's of x times the if. Okay, Bernoulli in y, so you can integrate with variable of integration, which is x. Okay, now Bernoulli in x, so x with the power of minus n plus 1 times the if, then the integral of, so a product of constant with the q's of y times the if, integrate that with the variable of integration, which is y. Now, if you are given a dE like this, now our dE is actually almost following a standard form. No? So we have a dy dx. So this is a Bernoulli equation in y. It is Bernoulli equation in y because if you have to check with our given, so there is y here with the power of 1, but in the other term, there is y whose exponent is not exactly 1. No? So, this is Bernoulli and this is how we arrange the term. So, the standard form may be written as our guide. Okay, so I can rearrange the term. Y prime can be my first term following the standard form. Then, the term involving a factor y can be its second term. Then, the other term that is containing y to a power, which is not 1. No? So, that can be part of the right-hand member of our equation. So, the coefficient of that which is purely x, that represents your q's of x. The coefficient of your y will represent your p. So, what is your p? That is equal to a minus 1 under this case. Q sub x is the product of negative x exponential of negative 2x. Your n is 3. So the minus n plus 1 is minus 3 plus 1, and that's minus 2. So you can now proceed with the IF. IF is equal to exponential of the integral of the minus n plus 1. So you do the substitution, that's minus 2. The piece of x is minus 1, is that right? Okay, then you have a dx. So when you integrate this, that will give you exponential 2x because the integral of this is 2x. Okay? So after knowing the IF, you can now proceed with the general solution. Being a Bernoulli in y, so you can start with y, but consider an exponent which is the minus n plus 1 with the IF multiplied. Then we have the integral of the product of minus n plus 1, the q sub x multiplied with the IF as your integrand. Okay, then do the substitution. Minus 2. This is your q. The minus x exponential of minus 2x, then it's multiplied with the IF, which is the exponential 2x. So these two have powers which are actually opposite. So this can be eliminated. Okay, so what is left is 2 integral of x dx. So if you integrate, there you have the x squared over 2. So 2 is eliminated. What is left is the x squared as its integral. No? So x squared plus c being an indefinite integral or a general solution. Okay, so then we can simplify. No? We can change the power to positive, taking its reciprocal. Or if I'm going to remove my denominator by multiplying with the LCD, so we have an answer which is the exponential 2x equal to y squared multiplied with the quantity x squared plus c. Okay? So that is how to solve a Bernoulli equation. Pero just to gain more familiarization on how to solve an equation under a Bernoulli classification, so we can have another example. So this is 2y dx. No? So if you have to check the linearity, murag linear siya in x because you cannot find, no? Di man kakakita o unsa, dili kakakita o term which is expressed as a function in x dx. But if you have to check, it's not linear because ang ato ang unsa, ang atong x dunay power which is in cube. Doon na sa term wherein the exponent of your x is 1. No? So this cannot be linear, but this can be a Bernoulli equation in x. So my guide is the standard form for the Bernoulli equation in x in order for me to rearrange my term following the standard form. So dx dy, my 2y can be used as the denominator of this expression. Okay, so following that arrangement of term, so we have x with the expression 6x squared minus y minus 1, okay, over 2y from this. Okay, then how do I arrange my term? The next term is a term involving a factor x. So I'll be looking for a term that can contain only a factor x. So this is x cubed. So this is not the term I'm referring to for my second term. But the y and minus 1, by distributing x over this expression, these two will contain a factor x. Both are negative. So I try to factor out the negative one and make the term as minus. So I have y plus 1 all over 2y times x. Okay, so this defines your second term. Now, your last term is kini. Over the same denominator of 2y, so this is 6 over 2, that's 3. 3 with y in the denominator, it's minus because we transpose. No? So there is x with a power of 3, so we can have n which is 3. The minus n plus 1 is minus 3 plus 1. That's minus 2. So what is my piece of y? That's the coefficient of your x, which is kini. Diba? So minus y plus 1 over 2y. The cos of x is minus 3 over y. Okay? The cos of y, is equal to minus 3 over y. So knowing all this, so you are now ready to find the integrating factor. What is the integrating factor following the formula? IF is equal to the exponential of the integral of minus n plus 1 we have the piece of y, okay, then the dy, because this is a Bernoulli and x. So what is your minus n plus 1? It's minus 2 na rin. Then you have your piece of y. Your piece of y is y plus 1 over 2y. Okay? So we have a dy. So this 2 is out, and that makes the term as positive because they are all negative. Now, if I have y plus 1 over y, then I can also divide each term of the numerator by the denominator because initially this is improper. So, to make it integrable, I have y over y that makes the result 1. I have 1 over y, so these two are covered with a different formula. What's the integral of y of 1 or integral of dy? That's 1. That is 1, so it is y, correct? Because we integrate only a dy. The dy over y is L in y. So we can write that also as exponential y plus L in y. And according to law of exponent, if we have a to a power n plus m, this is actually originating from a factored form of e to power n multiplied with a to power m. So if I'm going to rewrite this with a common base of e, no? So we have exponential y, exponential of L in y, because kine can be made as y. So it is a product of y and exponential y for your if. Now after knowing that, pwede na sad ka mag-solve sa imuhang general solution. Can you give me the formula for the general solution when that is a Bernoulli in x? So you can start with x with the power of minus n plus 1 multiplied with the if, which is having a value of this, and we have the integral of the minus n plus 1 times the cos of y multiplied with the if. So integrate that with the variable of integration y, then you can have the general solution. Okay? So this is the formula I was able to mention. So mo ni akong nahatag kanina. So I can now substitute the specific values. This is x with the power of minus 2. Then we have the if being evaluated. Okay? Then we have the integral of, again, minus 2. And the cos of y is minus 3 over y. And we have a product of y exponential y. So y over y, so this is out. What is left is exponential y. And we have a product of constant which is 6. Okay, so 6 integral of exponential y dy. So this is 6 exponential y as its integral. Changing the power to positive, I take the reciprocal. And if I'm going to remove my denominator, then I have my answer which is y exponential y equal to x squared multiplied with 6 exponential y plus c being our answer. Now actually, there's still last nga akong gidugang. Okay? So, niya na lang na si subscribe, no? Okay, so number 3. This is my given. This is already following a standard form of a Bernoulli equation. Pero dili obvious kayo, then I can maybe rewrite this again. Okay? Showing my piece of x and my q's of x. So, this is my standard form being my guide. Okay? Properly placed ang atong sa dy dx. So, kine, if there's a factor y, so the coefficient of that is 1 over 2y. Correct? And if there, I need a q's of x, so there is no other factor for your 1 over y except for 1, then y to a power which is minus 1. Because I need an exponent of my y. My y is in the denominator side, so it's good as y to a power of minus 1. So with that, pwede na ko mag-determine sa ako ang p, and what's my piece of x, that is 1 over 2x. The q's of x is the coefficient of y to a power of minus 1. In that case, on this case, we have 1. So the minus n, this is my, the n value, I mean. So your n is minus 1. The minus n plus 1 is equal to the negative of minus 1 plus 1. So we have 2 as the value. So pwede na ka mo continue into the integrating factor. What's the integrating factor? It is if equal to the integral, the exponential of the integral of the minus n plus 1 times the piece of x dx. So if you substitute the value of the minus n plus 1, that's 2. And if we have our p, is a piece of x, that's 1 over 2x, so 2 is out, that's dx over x. So that is an exponential of the ln x. No? So because that's dx over x, so we can simplify that being equal to x. Okay? So, after knowing your if, no, so you can now proceed with the general solution. Guided with the formula. So the formula can be equal to, what's our formula? So that is y to a power of minus n plus 1 multiplied with the if, diba? And that's equal to the integral of the minus n plus 1 multiplied with the cubes of x times the if. So integrate that with the variable x, then add your c, because this is a general solution. Okay, so it's y squared. No, so the minus n plus 1. Okay, so that is having a value of 2, then multiplied with x, and that's equal to the integral of 2 times, what's your q? 1. No? Then you have the if, which is x, so that is equal to x squared over 2, so 2 is eliminated, and then we can have the answer, which is xy squared, which is equal to x squared plus c, being our general solution. Okay, so that's all for the Bernoulli equation, and thank you for being with us. No? So I'm inviting you, if you are new to the channel, so just subscribe. No? So please subscribe and share this to others. Okay? Thank you for watching.